Morning, dear student. In today's lecture, we discuss the remaining reaction of your carbohydrate molecules. So, the reaction with periodic acid, this is your HiO4. It is also act as an oxidizing agent. So, in previous lecture, we already discussed the reactions of this glucose molecule with your oxidizing agent. Okay, Tollens reagent, then filling solution. So, in this lecture, we are very much interested in the reaction with periodic acid. So this periodic acid, it is act as an oxidizing agent. It break the carbon carbon single bond if both the carbon having hydroxyl group. So if there is a 1,2 diol is there, okay, so both carbon having hydroxyl group, then this bond should be break. This bond, that is carbon carbon single bond, should be break. So in this mechanism, both this hydroxyl group, uh, it having a lone pair on oxygen, it will attack on this electron deficient iodine, and there is uh, a formation of this complex, formation of this 1,2 diol, formation of a complex between this 1,2 diol and this periodic acid. So if we see the if you see this reaction, that is the lone pair of oxygen, it is attack on this iodine, and there is O minus. So this O minus will abstract this proton, and the charge on this oxygen get reduced, because the oxygen, it having a valency of 2, and it will form 3 bonds, therefore there is a positive charge. So to neutralize this positive charge, this O minus will abstract this proton. Similarly, in this case, this O minus also abstract this acidic proton. It will abstract this proton, and the charge on this oxygen get reduced. So what you get finally, so if you see this, what you get here, we get this, that is the carbon having oxygen which is attached to iodine, the carbon having oxygen, okay, which is attached to iodine, then there is a OH is there, OH is there, this OH is there, and there should be double bond O. So we get this intermediate, okay, and this intermediate undergo bond breaking and bond making. So this bond will shift here, this bond will shift here, and this bond will be goes like this. Okay, so what you get here, we get this, that is HC double bond OH. Again we get here HC double bond OH, and here what you get here, so if you see this, this iodine is there, okay, then there is a OH group is there, double bond O is there, here OH group is there, OH group is there, and there should be a negative charge on this. There should be a negative charge on this iodine. So the bond between this 1,2 diol, that is carbon carbon single bond, get break in presence of this periodic acid. And after that, after formation of this formaldehyde, so there is a formation of formaldehyde, HC double bond OH, okay, so it undergo hydrolysis reaction. So it undergo hydrolysis reaction with OH minus or what, so it undergo hydrolysis reaction with water, H plus and OH minus. This OH minus will attack on this carbonyl carbon, that should be O minus. So what you get here, HCH, okay, this O minus, and there should be OH, and this O minus will take the proton, okay, so it will takes the proton from this water molecule, and there is a formation of HCH OH, and here OH, and we know that the carbon having 2 hydroxyl group, it is unstable, it is unstable. The carbon having 2 hydroxyl group, it is unstable, and it will lose one water molecule. So finally what you get here, so after formation of this formaldehyde, it undergo hydrolysis reaction with water, and there is a formation of again unstable intermediate, and this intermediate with elimination of one water molecule, that is CH, H, OH, OH. So in this case, if you write this like this, that is CH HOH and here OH. So the lone pair of this oxygen will abstract this proton and the bond get shift here. Okay, and this water molecule will be leaves out. So what you get finally, H C double bond O. Okay, so here formation of OH2 positive. Okay, and here should be hydrogen. Okay, and this water molecule will be leaves out. This water molecule will be leaves out. Okay, so we'll discuss. That is H C double bond O H. So we get this formaldehyde. So we get this formaldehyde in this case. So you should keep in mind whenever the reaction with periodic acid, so there is a cleavage of carbon-carbon single bond between the carbon having two hydroxyl group and which undergo hydrolysis reaction. So let us discuss the reaction with your glyceraldehyde. The reaction with your glyceraldehyde. So glyceraldehyde is your carbohydrate molecule. This is your C double bond OH. Okay, then there is a HOH, HOH, and finally there is a CS2 OH group is there. So all these bond get cleaves. Okay, so this is your 1 2. Okay, this is 1 2 3 and 4. Okay, this is your if you consider, this is your I will make mistake. So this is not your glyceraldehyde. Glyceraldehyde is your tri-H sugar. So this is your C double bond OH. Then there should be HOH, and finally there should be CS2 OH. Okay, so this is your 1 2 and 3. This is your tri-H sugar, and all this bond between carbon first and carbon second and carbon third get break in presence of HiO4. So we require two molecules of HiO4 minus, and we know that. So after breaking of this bond, okay, after breaking of this bond, okay, so there is a formation of OH group. There is a attack of one OH group at each carbon. So what you get after cleavage in presence of this periodic acid, here we get C double bond O H, and here, so what you get here, so we see the reaction, that is this okay, this glyceraldehyde, on cleavage, so this bond get cleaves and this bond is also cleaves. After cleavage, there is a we can write here here C double bond O H, and there is a one OH. Okay, similarly this is carbon number 1. So what you get here, so we get this formic acid in second carbon. So HCOH is already there, so there should be OH after cleavage of this one and second carbon atom. The bond between first and second carbon atom, there should be one OH, and after breaking of 2 and third carbon atom, there again there is a one OH group is there, and we know that the OH group, it is not more than one OH group. It is not a stable species, it is unstable species. So it eliminate one water molecule, so it will abstract this proton. The bond between oxygen and hydrogen will be shift here and it will be leaves out, and there is a formation of H C double bond O and OH. Again we get what, the formation of formic acid. Again we get the formation of formic acid. This is your carbon number 2nd, and at carbon number 3rd, so carbon 3rd, it is already having hydrogen, it having one OH group is there, and after bond cleavage the one OH group is there. So we already discussed the mechanism of this periodic acid. So whenever your carbohydrate molecule, it will react with your periodic acid, then there is a formation of, then there is a cleavage of carbon carbon single bond, and this species is converted into carbon oxygen double bond. Okay, this species is converted into carbon oxygen double bond, which is on hydrolysis it will gives different product. So after hydrolysis we show this reaction. So after each bond is get break, then one OH group is attached to carbon 1. After that one OH group is attached to this carbon second. When the carbon 1 and carbon second bond get break, after breaking of this carbon number 2 and carbon number 3 bond, one OH group is attached to this carbon number second, one OH group is attached to carbon number third. So in this case also both OH group attached to the same carbon and it is unstable. Again it will abstract this proton, the bond will be shift here and this will be leaves out. So what you get finally, we get here H C double bond O H. So we get here formaldehyde. So we get here formaldehyde. So you should keep in mind, whenever the glyceraldehyde it react with your two molecules of this periodic acid, it will forms two molecules of formic acid. So in this case we get two molecules of formic acid, and this is your one molecule of this formaldehyde. Okay, so in next lecture we will discuss the remaining reaction of this carbohydrate molecule. Thank you.